All right, good morning, folks. Today we are going over our second circuitry lesson. That's two of three. And we are going to be talking about voltage today. So, last circuitry class, we talked about what is a circuit. And a circuit just basically is a pathway through which electricity can flow. And we talked about what is a battery. So, when you have electricity flowing, okay, I'm going to make sort of a diagram on the board here for you guys to see. I have this right here and then this right here. And in those spots is some amount of electric charge, some electricity. Okay, I'm going to just put 8 here and 0 here. It's kind of like water pressure, you guys. Um, but if I go ahead and, oh, I need a better eraser for sure. If I connect those with a pipe, now what do we have happening here? We have electricity flowing through that pathway, right? From an 8 there to 0. Now, how long do you guys think it's going to flow? You think it's going to get all of this over to here, to the other side? Let me close that up at the top. Is it going to flow until this says 0 and that says 8 over there? No. What you guys are probably figuring out is that it's going to flow until it's the same, right? So until that is 4 and 4. So when we have a battery, what a battery essentially is, this is all review from the first class, is a battery is one box like this, and it has a wall in the middle of it, big wall that nothing ever passes between that wall. Nothing goes through the wall. And then we have one side with a bunch of electricity and one side with not so much. Okay. And then what do we do with the battery? We create a pathway for the electricity to flow through, right? This pipe, like this. So this is our circuit with a battery, okay? So when you have your electricity flowing, it'll flow, right, until it's even on both sides. Now, the relative strength of these, this is called voltage, okay? Voltage is the difference in electric charge between 2 points, okay? Now, if you guys have ever seen flowing water doing work, like moving a water wheel, okay, this is sort of the same sort of concept that we do with electricity. Flowing electricity can be made to do work. In fact, you can move a wheel with it. You can create a motor. You can also light an LED, which is what we did in our last project, Circuitry Class number 1. We used LEDs and lit them with our battery, okay? Now today we're going to sort of get an understanding of what is the necessary strength that this needs to be for a battery to light, or for a battery to light a light or to move a motor. So do you guys have kind of an idea about that? We're going to cut over to the project table here in just a moment. My cat is on my desk there. He's going to have to move. Let me go ahead and walk on over to our project table and get set up over there. Excuse me, sir. You gotta move. All right. So we're going to cut to the other camera. So these are our project materials. We had a few project materials still left over from last time. We have a lot of this copper tape and a lot of these batteries still. But what we did last time is on our paper right here, we went ahead and made a pathway for electricity to flow using this copper tape right here, which sticks to the paper. So now our class today, being about voltage, we're going to take a look at some voltages, okay? This right here is called a multimeter, and it's called a multimeter because it does multiple things. Pretty creatively named, huh? We're going to get some of these things out of the way, the markers, the LEDs, and with just our multimeter here. Now, I would like to see if I could perhaps flip this view because this multimeter is presently upside down to me. Let me see. This is how I'd like to have it, but then it's upside down for you guys. Can I mirror my video? Oh, I can, but it mirrors it not the correct direction. All right. Well, I think we're going to compromise here, and maybe I'll hold it sideways. Anyway, we have various things that the multimeter can do. If you guys sort of look here, I'm going to actually bring it up closer to the camera so you can see. Now, a multimeter can measure voltage, can measure resistance, can measure current, can measure all of these things. And you see that each sort of thing that it can measure has its own sort of space here on the multimeter to switch it to do various different things. Now, the thing we want to do is measure voltage. So we have a little icon here in this section, has a little V and two parallel lines, okay? That means if we use any of these settings right here, sorry, those ones, then we are using the multimeter to measure voltage, okay? So that's what we want to do here today, okay? So our little knob needs to be pointing at one of these little spots here in the voltage measuring section. Now, the voltage measuring section, it has 1, 2, 3, 4, 5 potential places that I can click it. Now, what are all those places? If I look very closely on the multimeter, I can see it has what are called ranges, okay? It's maybe difficult for you to see. It's not very focused well, but we have the first one says 200M, and the next one says just 2, the next one says 20, and the next one says 200. Now, we need to make sure the multimeter is set to the correct range, okay? So if I'm expecting to measure a couple of volts, I probably want it to be on the 2 range, not the 1000, okay? So what am I expecting to see from this battery? This is our coin cell battery that we were using from the first lesson. Does anybody have maybe a guess at what they expect to see from this battery? Now, I can look at the battery, and written on it in this silver writing, it's almost impossible to see on the camera, but I can see it quite easily if I put my face close to it. And it says CR2032. That's the type of battery this is, the form factor, the size, all that. And then next to that, it says 3V. So what do you think that means? That this is a 3-volt battery, okay? Let's go ahead and measure the battery and see if indeed we do get 3 volts, okay? Let's check that out. I'm gonna get my probes plugged into the multimeter here after I untangle them. All right, so the end of the black probe right here goes into the black right there. And then my red one is gonna go into the red plug right here. Alrighty, so I push the on button and right away it just says 0. The probes are just like this. All right, so let's go ahead and measure our battery. I'm going to put it upside down so it's easier for you guys to see. And I touch one side of the battery, right? And then the other side down there. -1. That can't be right. Do I have the right range? Let me go ahead and click up to 20. See what that does for me. All right, it says minus 3.1, and that's because I actually have the probes on here the wrong way. I'm touching the minus probe to the plus side and the plus probe to the minus side. So if I switch that around, there we go. You see I have 3.19 volts from this battery, okay? Now, remember, our diode, a one-way gate through which electricity can flow, has to go on there the correct way for it to light. Is that the right way? No. Is that the right way? Yes. All right. So on there, 3.1 volts will go ahead and cause us to light. Now, as I sit here with this light on, the current is flowing through. The electricity is flowing through. And what do you think is happening? Do you think that number, that 3.19, is staying the same? No, it's emptying out. It's going to the other side of the battery. So it's actually reducing. Now, the light is a very, very tiny pipe, and only a small amount of electricity flows through it. So it doesn't drain it very quickly. In fact, it takes a long time for an LED to completely run out a battery. Let's see if sitting here like this has at all reduced the voltage of the battery that we can detect. I'm going to take this off now. I'm going to go ahead and put the probes on. In fact, it has. Look at that, you guys. Down to 2.8. Now we know from this then that 2.8 is still sufficient voltage to light the light. You guys want to do an experiment here? Let's go ahead and see how long this will stay on here. I'm going to grab actually some other kind of tape to use. We're going to see how long the battery will light the light if we just leave it on there. So I'm going to tape it on there. And what we should find is that eventually it goes out. And what we're interested in is when it goes out, what does the battery voltage say? Okay, let's try that experiment. What's the minimum amount of voltage required to light this light? Okay, you know what? I don't even need to tape it. It looks like it's quite content to just sit there like that. I'm going to go ahead and sort of get this in the corner of the screen so you guys can kind of see it as we work on other stuff. Okay. There we go. So that's just going to sit there while we're doing some other stuff. Let's take a look at some other batteries, you guys. I have, in fact, a bunch of random batteries here. Look at this. These are some old batteries that I've taken out of remotes and other things like that. I've got some AA batteries, and I've got a 9-volt battery here. Now, the 9-volt battery is called a 9-volt battery, so you would expect that when it's new, it has 9 volts in it, right? Let's go ahead and see what this battery presently is measuring, okay? I'm going to go ahead and touch the plus side there and the minus side there. This battery has 3.05 volts in it, okay? Now, we know that our LEDs require about 3 volts. The other one was working with 2.8. So this would be a nice battery to save up and use LEDs. So maybe we can use this for another project instead of a coin cell battery. We can maybe keep this. It's still useful. But at 3 volts, it certainly doesn't have the ability to power something that requires it to be 9 volts or maybe 8 or whatever it is that the device requires. So we're going to set that one over here. Let's try one of these AA batteries. Now I can look at it and see what is the voltage that this is supposed to have. Does it have it written on there? It says AA, and then it says 1.5 V. So the battery, the little writing on here, does indeed say that this is supposed to be a 1.5 volt battery when it's new. Okay, so let's go ahead and check this one out and see what its level is. Okay, that says 1.49. Okay, that seems pretty much like new still, huh? This is not a dead battery. We can actually set that aside as a useful battery. Let's check this one out. 1.49, also quite new still. What do we have here? All right, this is 1.27, so that's pretty low, right? This is definitely a dead battery. What do we have here? 1.34, okay, that's still pretty low. I guess that's probably dead. What do we have here? 1.29, okay. So these are pretty dead batteries. 1.29. Now, our little light over here is still working, so that battery is still pretty good. But do you think 1.29 volts is going to be strong enough? It's going to be enough voltage that we can light an LED with it? Let's see, you guys. 1.29. Uh-oh. Well then, looks like I can't quite get one end of those onto there. Okay, so what am I going to do here? Well, what I'm going to do is I'm going to make something out of copper tape and paper, okay, that I can hold the battery here with, okay? So what do I want to do? I want to create a circuit. Let me take this away for right now. I want to create a circuit that, right, goes like this and then comes to here. And then the light can be right there. How do we feel about that? Pretty good, huh? So let me just cut off a smaller piece of paper. Okay. Probably would have been better maybe if I had like an index card for this, but you know, a bit of paper is fine. So I have my copper tape, and my copper tape, let me just sort of draw out the pathway of the circuit. Okay, it's going to go like this, it's going to go like this, and then this, and then like that. And my light's going to be right there. All right, so the longer one needs to be at the plus side. My plus side is the little bump end right here. That's my plus side. And then my minus is over here. Okay, so let's go ahead and get my little light stuck down with tape. Okay, right there. That looks like it's about where it needs to be. My tape is going to go like this. Let's go ahead and, oh, I did just cut my nails last night, so this is a little bit difficult for me. Actually, this is very difficult for me. How am I going to do this? There we go. All right, I did get it peeled. I got to do that a couple more times though with these other segments. So maybe a little slow going for me here. So I tape the leg down of the LED over there, and gonna get the other leg tape segment done. So it's like this much, and whoop, excuse me, that guy kind of rolled away. Alrighty. Uh-oh, that did not peel correctly. Oh no. Let me try to get it from the other end. Oh no. There we go. I've got the copper tape peeled up off of there now, and we're going to put the other LED down, other LED leg rather, and then we're also going to go from here to there, right? I'm going to make 2 pieces that size, all right, there, and then this one. Let's go ahead and get this peeled from there. Very nice. And just a reminder from last week, this material is pretty delicate and it's easy to kind of mess it up, you guys. So a little bit of patience perhaps is required with this. Don't get too frustrated. It's easy for it to kind of curl up and stick all together and make a mess. So one tip that makes things a little bit easier is it's great to work with smaller segments like this. You certainly don't want to pull a long giant piece out like that. All right, now just 2 more little segments so I can fold this paper over and touch the ends of the battery here. So we have whoop, that little bit and whoop, that little bit. So this first piece, there we go. We're going to put that there, my minus side. All right. And then my plus side. Looks like my little battery, my coin cell battery, is still powering the light quite easily, huh? All right, we got that little segment off of there. All right, let's see if 1.29 volts will light our light, you guys. Uh-oh. So that's there, and that's there. Now, it's not lighting the light, huh? What I'm gonna do, you guys, is show you that there is indeed 1.2 volts here. Okay, how are you gonna do that, Mr. Blake? Well, I'm going to tape my probes down, is how I'm gonna do that. So, let's go ahead and do that. I get this piece right here. So difficult. And we are going to tape the probes down. All right. There we go. Use a little bit of more than I need to just for it to be sort of, structurally sound there. This little bit of extra stuff isn't going to be a problem for anything. So oh, there we go. Let's get this multimeter probe put down as well. All right. Now, get this in here and let's confirm that we do have 1.29 volts, huh? See what that looks like. Okay. Yep. Oh no. All right. 1.29. You guys can see, and my light, my little LED in the circuit is not coming on with 1.29 2625 volts. Okay, so that's a problem, right? Let's see. Let's get one of my good batteries, right? The one that was 1.4 something, and see if 1.4 is enough to light an LED, huh? All right, it's not going on, you guys, and that is 1.49 volts, but it's not going on. So what did we learn here today? Well, we learned that 1.49 volts is not enough to light an LED. Okay, now the one that we got going on over here in the corner is still going strong. Okay, how low do you think the battery will get until it stops lighting the LED? Do you guys think that it'll get all the way down to, who says 2.5 and then it goes off? What do you think? 2.3? Who thinks the battery's gonna light the light still when it's at 2 volts? 2.0. Does anybody have an idea about that? This is an interesting project for you guys to perhaps do at home. You can get yourself a coin cell battery and an LED and just go ahead and clip it on there and leave it for as long as the LED will remain lit. Okay? That's a pretty easy project you guys can do. Leave it on there and then go ahead, come back with your multimeter, and then go ahead and measure the voltage of the battery. And at that voltage, it will be just weak enough that it can't light the light, and it won't be any lower than that. So we're going to go ahead and wrap things up here now, and finish our lesson. So thanks for tuning in here with me today, you guys, and feel free to join me tomorrow for this same lesson again in the morning, lesson 2 of 3 in the circuitry class. Today we covered the concepts of voltage, what is voltage, and then the multimeter. What do we use the multimeter for? Well, today we used it to measure voltage. We can measure electricity in all kinds of other ways as well with a multimeter. You can see the various sections around here of the various types of ways it can measure things. And yeah, thanks for tuning in. Also, lesson number 3 of 3 will be next week at the same times, 9 o'clock in the morning on Wednesday, Thursday, and then Friday. Friday is the paid session if you guys want to attend that and not be recorded. The Wednesday and Thursday sessions are recorded, but they are free if you guys want to attend them. So thanks for spending time with me today, you guys, and have a good day. All right.